Welcome back. In this video, I will explain how you can use tables to find the logarithm of a number greater than 1. In the last video, I explained how you can solve a logarithmic equation using the principle I gave. Don't forget, I gave you the principle and the relationship connecting the indicial equation as well as the logarithmic equation. If you don't forget, I said when you have log n base a equals x, then this implies that your n is equal to a raised to power s. So it implies that your n is equal to a raised to power s. Don't forget, this x is the logarithm of this number n to this base a. You understand? In essence, when I have my common logarithm, don't forget the common logarithm is the logarithm so in which the base is 10. So if I have logarithm of 100 base 10, we know logarithm of 100 base 10 is equal to 2. Then you can rewrite it as an indicial form. This will give you 100 is equal to 10 raised to power 2. Again, this is your logarithm. So this is your logarithm. So one of the applications of logarithm is that you can use it to simplify cumbersome expression or cumbersome simplification without using your calculator. For example, when you have this kind of expression or this type of problem, 54.86 multiplied by 3.08, so divide by 0.81 multiplied by 4.205, everything raised by 3. So, and you have 4th root here. So you will see that if you want to use and to solve it, it is difficult and it will take much of your time. So, but you can easily do this using what? Using your logarithmic table without using calculator. What we call logarithmic table? So when we say logarithmic table, a logarithmic table is a kind of table in this form, so whereby it consists and it contains the log of numbers between 1 and 10. It contains number between 1 and 10 if you check it very well. So you will see that the logarithm of this number is 0. You understand now? And don't forget, the logarithm of 1 is what gives what? So what gives 0? And if you check the last number here, you will see it is not up to 1 as well. So then that's why I said when you have your logarithmic table, it contains the log of number between what? Between 1 and 10. So in essence, when you are asked to find the logarithm of a number that exceeds the range of 1 and 10, that is greater than 10, what you have to do is to what? Is to rewrite in standard form. Don't forget the number I said is to be in standard form. If it's of the form a multiplied by 10 raised to power n. So where your a is a number between 1 and what? And 10. And your n is what? And your n is an integer. And your n is an integer. At times, you can call your n your characteristic. You understand now? So you are going to see how you can use that. How you can use your table to solve logarithm. So before I continue, let me give you an example to understand what I'm trying to say. Example, use logarithm table to find the log of number 1, I have 3.6. Number 2, I have 36. Then I have 3,600. Okay, now this is not difficult to do. If you follow the explanation I gave the other time, then you can simply solve this. How do you do this? Don't forget, with the explanation I gave here, I said when you said logarithm of a number, let's say you are working in base 10, logarithm is the power to which this 10 is raised. You understand now? So it means you can, if you rewrite this as a number in base 10, let's say, for example, I have my 3.6. You know, you can write this in standard form. Don't forget how you can convert number to a standard form. If you've forgotten, I refer you to my video on standard form. So this will be what? 3.6, then multiply by, I said you count the number of digit before the decimal point. How many number of digit before the decimal point? So that we have one digit before the decimal point and you subtract one from it. So you have 1 minus 1, you have 0. Likewise, we want to convert this to standard form. Don't forget, that will be 3.6 multiplied by 10 raised to power. You count the number of digits you have. That's 4 digits. So if you now subtract 1 from it, so you have 3. So you understand that. So if that is clear, so then we have this to be 3.6 multiplied by 10 raised to power 0. Then it means you can check this in your 4-figure table, in your logarithmic table, since it falls within the number between what? Between 1 and 10. And here you are just going to check 36. You understand now? You refer back to your logarithmic table. So if you go back to your logarithmic table and check 36 here. So under 0, so then you have 5563. So 5563. I hope you understand. This is what I do. This is what I did. So you have your 36 here. You understand now. Then you select it here. So that's 5563. Then you put it in front of it now. Then you can say this is 10 since it is logarithm. Don't forget logarithm is the power. So to which a base is raised. So then you can say this is what? 0.55. So 0.5563. Do you understand why it is 0.5563? Remember I said the logarithm table consists of what? The logarithm of number between 1 and 0. So it means even if you are counting, I mean, if you find a number here, the logarithm of 1 here is 0. So since you've not reach the logarithm of what? The logarithm of 10. Remember the logarithm of 10 is the one we give you 1. It means any number you have in between 0 and 1, then sorry, in between 1 and 10, then it still falls in between what? In between 0. That's why we have 0.536. You understand? For example, you know I said it 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 contains logarithm of number between 1 and 10, and we know the logarithm of this 1 is what? 0, and the logarithm of what? Of 10 is what? Is 1. So it means any number between 1 and 10 here, so which you have will be 0 point something. You understand now? So in essence, when you want to find the logarithm of 3.5, for example, then it's going to give you what? 0.5441. You understand now? So then if that is cleared, then you go back here. So then this will give me multiply by 10 raised to power 0 again. You can see this as you have indices here, and the relationship between the two index is what? Two indices is multiplication. And don't forget, I told you in the previous video, when you have something of this nature, a raised to power m multiplied by a raised to power n is going to give you a raised to power n plus n. Then this is going to give me 10, 0.5563 plus 0. So then that will give me what? 10, 0.5563. You understand now? So in essence, your logarithm 3.6 to the base of 10, remember, you may decide not to write the base because we are working in a common logarithm, which is 10. It's going to be what? The power to which 10 is raised. So you understand now, that will give you 0.5563. 0.5563. Okay, now what of the second one? It is not difficult as well, 36. Recall 36 is a number that has exceeded what? 10. So it means we have to rewrite this in standard form first. This will give me 3.6 multiplied by, how many digits is this? 2. You subtract 1, then this will give me 10 raised to power 1. So then if this is 10 raised to power 1, then you find the logarithm of this. Don't forget the logarithm is what? Is the power to which 10 is raised. And like we found the other time, so we found it to be what? 0.5563 multiplied by 10 raised to power 1. So then if you now apply your laws of indices, I have 10, 1 plus 0.5563. That's going to give me 10 raised to power 1.5563. In essence, logarithm of 36 is going to give me 1.5563. So lastly, you have your 3600. It's not difficult to do. Convert it to standard form. Remember, this is going to give me 3.6 multiplied by 10 raised to power what? How do you find the index? You count the number of digits. The number of digits here is what? We have 4 digits. Then you subtract 1 from it. That will give me 3. You understand now? And the logarithm of this, that's 10 raised to power with what we obtain here, 0.5563. So then multiply by, so that's multiply by 10 raised to power 3. If you apply your laws of indices, you are going to have 10 raised to power 3.5563. So 10 raised to power 3.5563. Therefore, logarithm of 3600 is nothing but what? 5563. So if you observe from the 3 example I did, that of log 3.6, 36, and 3600, you will see that the logarithm of any number, for example, when I find log 3.6, we obtain the result to be what? 0.5563, right? Likewise, log 36, 1.5563, right? Then log 3600 is what? 3.5563. You understand now? You will observe that the logarithm of any number, for example, the 3 example I did before, so contains 2 parts. You understand? So the first part here, that is the part before the decimal, is known as the characteristics part. Characteristics, characteristics part. You understand now, which is also the same thing as integer part. So these are the part before the decimal number, the old part. And those after the decimal like this are called the what? The decimal part or the mantissa. So I call the decimal part or the mantissa. So in general, if you want to find any logarithm of a number, you don't need to stretch yourself and convert to standard form. Just find the characteristics and find the mantissa. How do you find the characteristics of a number? You are going to know the characteristics of a number by counting the number of digits of that number and subtract 1 from it. You understand now? That's the first way. The second method you can use to find the characteristics is to convert the number to a standard form and you write the power to which 10 is raised. So, but for you to find the mantissa is obtained from your 4-figure table. And how do you do this? Then you are going to look up the numbers from the 4-figure table. Let me give you an example to back it up. Example number 1, I have used logarithm table to find the following. Use logarithm table to find the following. Number 1, I have 57.34. Number 2, I have 234.6. And number 3, you have 5647. This is not difficult to do. Remember, I told you that logarithm of a number has 2 parts. So the first part is what? Is the characteristics part. So that is the part before the what? Before the decimal. So this is the characteristics part. Likewise, we have the mantissa, the one after the decimal. You understand now? So, and don't forget, I told you before, you can find the characteristics part of a number. You count the number of the digit before the decimal point and subtract 1 from it. Alternatively, you can just write the number in standard form and write the power to which the number is raised. So how many digits do we have before decimal point here? 1, 2. We have 2 digits. You understand now? Then you subtract 1 from it. 2 minus 1 will give me 1. Then the characteristics part of this number is what? It's 1. Then you now use the number to find the mantissa. You look up this number on your what? On your logarithm table. And how do you do this? You now get rid of this decimal point such a way that you have what? 5734. Then you go to your logarithm table. In your logarithm table, you now check 57. Since we have 5734, you now check 57 under 3 difference 4. So this is 57. Let's move to 57. So this is 57. So you know you have your 57 here. Under 3, you check under 3 here. So this under 3, that's 5782. So difference what? Difference 4. Then you now check the difference colon, the one corresponding to 57. You know difference 4 here is what? Is 3. So difference 4 is 3. Then you now add 3 to what you obtain here. You understand now? We check 57 under 3, that's 5782, difference 4. The value you obtain from the column of difference 4, you are going to add to what you obtain in your logarithm, and this will give you 7585. Then you now go back to your question and write it 7585. What we did, we find the characteristics part first, then we use this number to look it up on the four-figure table. So that is, we find 57 under 3 difference 4. So, and that's how we obtain this. Okay, now let us do the second example. So remember, logarithm of a number contains two parts. The first part is what? Is the characteristics part. And for you to obtain your characteristics part, you count the number of digits before the decimal point. That's 1, 2, 3. How many digits? That's 3. Then you subtract 1 from it. You have to remember, another method you can use is to what? Is to convert this number to a standard form. That will give me 2.346 multiplied by 10 raised to power. Don't forget, I told you remove the first number and you count the number of digits after it. 1, 2. That is 2. You understand? That's how you obtain your characteristics part or the integer part. So, but for the multiplier, you use this number to, you look up this number on your logarithm table without minding this what? This decimal point. It means I have 2, 3, 4, 6. We have 2, 3, 4, 6. And like I've explained in the first example, how do you check this? Then you are going to check, you choose the first two number here. So then you check 23 under 4 difference 6. So 23 under 4. This is 4. So corresponding here. So you have 23 under 4. Then difference 6. You know this is your difference 6. That is 11. Then I have 3, 6, 9, 2 plus 11. Don't forget, I told you are going to add the difference. This will give me 3073. Then you have 30. So 3703. I think I'm doing 23 under 4. That's 3692. Then difference 6. Let's check it again. Difference 6 here is 11. Yeah. Then this is 307. So you have 3703. So you have 3703. And the last one is not difficult as well. What is your characteristics part? Remember, so you count the number of digits and subtract 1. We have 4 digits here. If you remove 1, you have 3. Then this will be 3 points. Then what are you going to look up in your four-figure table? That's 56 under 4 difference 7. Let's go back. 56 under 4 difference 7. So 56 under 4. This is 56 under 4. That's 7513. So the 56 under 4 difference 7, right? So difference 7 is 5. You put your 5 here. Then this gives me 7518. So 7518. Then you put it here. So then you have 3.7518. You can see that's not difficult to do as well. You find your characteristics part, then you follow it with your mantis, and don't forget you look up the number you are given in your four-figure table. That's how you can find the what? How you can find the logarithm of a number. So, but what of antilogarithm? Antilogarithm is the reverse process of logarithm. You understand now? Remember here that we have logarithm of 57.34 is what? 1.7585. You understand now? So the number whose logarithm is given, you understand now? The number which if you want to find the number which logarithm is given, then you take the antilog of this. So that will give you 57.34 back. And how do you do this? That's not difficult. So what you are going to do is to check in your antilogarithm table. You check the mantissa part, you look up the mantissa part in your antilogarithm table. So and you now do what? And you use the characteristics part to place the what? To place the decimal point. For example, if I want to find the antilog of this number, that is the number whose log is given, then you are going to look up for 0.75 under 8 difference 5 in your what? In your anti-logarithm table. Don't check it in your logarithm table. If you check it in your logarithm table, that's rubbish nonsense. So you are going to get what? 0. So okay, likewise, if you want to find the anti-logarithm, that is, you want to obtain this number back, what are you going to get? What are you going to find? Then you are going to find 0.75 under 1 differentiate, and you are going to use this mantis characteristics part to place the decimal point. Okay, let us do that. The first one here, we want to find the antilog of 1.7585. What are we going to say? Check, like I've said, we are going to check 0.75 under 8 difference 5. Don't look it up on the logarithm table. You move to your anti-logarithm table. So you move to 0.75. You check 0.75. 0.75 is this. Under 8, you check the one corresponding to 8. That's 5728, right? Difference 5. So you check the difference 5. I think that is 7. You have 5728. Don't forget you are going to add the difference plus 5. That will give me 5375. You understand now? So then I'm going to have what's back? So 5735. So it is because we rounded, you know, for all the number you check from your four figure table, it is rounded up to 4 decimal point. That's why you didn't get, this you have the last digit here to be what? To be 5. And don't forget that's not significant since you have it after the decimal point. Okay, now since you look up this on your anti-logarithm table, I told you you are going to use your what? Your characteristics part to place the decimal point. You understand? Now you now say before we can write that our characteristics part is 1, then how many digits do we have before the decimal? You understand now? That's 2 digits. Recall here, how many digits we have here? We have 4 digits here. Before we can write our characteristics part to be 3, what we did was that we subtract what? We subtract 1 from it to have 3. It means when you have your characteristics part to be 3, it means the number of digits you have before the decimal point is actually what? Is actually 4. You understand now? So since my characteristics part is 1, then you are going to add 1 to it. So that will make it 2. It means you are going to have 2 digits before the decimal point. Then you now count it like this: 1, 2. And your decimal point is going to be here. And your decimal point is going to be here. Another example, use antilog to find number 1, 10 raised power 2.9274. Remember, that is the logarithm of this number. What you obtain, is just like when you are having malaria, you take anti-malaria. You understand? Now you want to remove logarithm from this number. That is the number whose log is given. You want to know it. Don't forget what I asked you to do. You use what? You look up the mantissa from your what? From your logarithm table. What are you going to check this time around? That's 0.92 under 7 difference 4. 0.92 under 7 difference 4. 0.92 under 7 difference. This 0.92. Let me check the difference very well. 0.92 under 7. This is 7, right? You have to be careful. You check the number corresponding to it. Difference 4. If you check the difference 4 here, difference 4 is what? Is 8. So then you are going to have 8, 4, 5, 3 plus what? Plus 8. Is that taken? So that's 1, 6, 4, 1. So then I'm going to have 8, 4, 6, 1. So I'm going to have 8, 4, 6, 1. 8, 4, 6, 1. And remember, you are going to use your characteristics part here to place the decimal point. Before we can have our characteristics part to be 2, it means we actually have how many digits? We have 3-digit number. So then you just add 1 to 2 to make it 3. Then you count it 1, 2, 3. So then you have the logarithm of this number is 8461. So if you want to find the logarithm again back, just find what? Check 84 under 6 difference 1, since you know that your characteristics part is 2. That's how to find it. So last example, let's say you want to find the antilog of this number 0.6894. What you are going to check is what? That's 68 under 9 difference 4. 68 under 9, this is 68 under 9. You have 4887. So difference 4 will give me what? 4. Then you have 4887 plus 4, that's 1984. Then you have 4891. So that's 4891. And you are going to use your characteristics point here to what? The characteristics part to place the decimal point. Before I can have 0 as my characteristics part, it means the number of digits is 1. So that is you add 1 to this 0, making it 1. Then you now count it 1. So then you have your decimal point here. That's not difficult to do. Remember what I told you, that logarithm of a number lies between 1 and 10. And remember I told you logarithm of a number has 2 parts. So that is the characteristics part. Then you have your mantissa, that is the number after the decimal. The one before the decimal, the part before the decimal is called what? Characteristics part. And if you want to check the logarithm of a number, find the characteristics part by counting the digits of that number and subtract 1 from it. For example, if I want to find the logarithm of 4891, then the number of digits here is what? Is 3 points. Then you look up this number in your logarithm table, that's 48 under 9 difference 1. And the first price of logarithm, you want to obtain the number whose logarithm is given, you take the antilog, just like when you are having malaria, you take the anti-malaria. So then if you want to find the antilog, what you are going to do is to what? Is to look up the mantissa on your antilogarithm table, and you use what? And you use the characteristics part to place the decimal point. So that's how you can find the logarithm and antilogarithm of a number. So in the next video, I'm going to explain how you can use this logarithm table for calculation of number that are greater than 1. So please, if you understand this video and enjoy it, please don't forget to like, share, and ask your friend to do so. I will see you in the next video. Thank you.